So now, as I promised in the last video, I'm going to show you how to wrestle a matrix into reduced row echelon form by yourself. If you want to do it without a calculator and take care of all the steps yourself, here's how that would work. Now, my strategy is to take it one column at a time. So we're going to focus on this first column here and getting it into the way we want it to look, which means we want it to have a 1 up here, so that will be the leading one of that first row. And then we want it to have zeros here and here, because everything else in that same column of that leading one is supposed to be a 0. So how can I'm going to work on getting the 1 in place first, and then I'll worry about the zeros. How can I get a 1 up here? Well, notice there's already a 1 down here, so the easiest thing to do, seems to me, is just have these two rows switch places. So that's what I'm going to do. I'm going to interchange rows 1 and 3. So when I do that, row 1 becomes 1, 0, -3, -2. Row 2 is still the same, 3, 1, -2, 5. And row 3 is now 2, 2, 1, 4. Now that I have the 1 in place, next thing I want to worry about is getting zeros here and here. So look in this middle row where there's a 3. How can I turn a 3 into a 0? Remember, what I'm allowed to do is I'm allowed to interchange two rows. I'm allowed to multiply or divide everything in a row by some non-zero number. Neither one of those is going to help me, but the third thing is going to help. I'm allowed to add a multiple of one row to another row. Can you think of something that I could add to a 3 to turn it into a 0? What can you add to a 3 to end up with a 0? Answer, its natural enemy, the -3. So where am I going to get a -3 from? Well, see this 1? If I take -3 times this 1, that will give me a -3. So I'm going to be taking -3 times row 1 and adding it to row 2. So row 1 itself does not change. It's still going to be 1, 0, -3, -2. But row 2 is going to change. Instead of what's there now, I'm going to replace that with -3 times what's on top plus what's currently in the middle. And I'm going to do that all the way across. So -3 times 1 is -3, plus 3 is 0, just like we planned. But continuing that the rest of the way across, -3 times 0 is 0, plus 1 is 1. -3 times -3 would be +9, plus -7, or plus -2 would be 7. And then -3 times -2 would be +6, plus 5 would be 11. Now, what about down here? There's a 2 where I want there to be a 0. How can I kill off a 2? What can I add to a 2 to turn it into a 0? Well, the natural enemy of the 2 would be the -2. Where am I going to get a -2 from? I'm going to take -2 times what's in row 1, and then I can add that to row 3. So I'm taking -2 times row 1 and adding that to row 3. -2 times whatever's on top is getting added to whatever's on the bottom. So -2 times 1 is -2, plus 2 is 0. -2 times 0 is 0, plus 2 is 2. Negative 2 times negative 3 is positive 6, plus 1 is 7. And negative 2 times negative 2 is positive 4, plus 4 is 8. Okay, now I am done with column 1. Column 1 looks exactly the way I want it to look, so now I turn my attention to column 2. So in column 2, what I want is for there to be a 1 here in the second row, because that's going to be the leading one of row 2. And then I want there to be zeros everywhere above and below that. So first thing I want is for there to be a 1 right here. And yay, there already is. We caught a break. We don't have to do any extra work about that. That's already what we want. So next, we want zeros everywhere else in that column. And there already is a 0 up here. We caught another break. We don't have to do any work to get that. But we do have to do some work down here. We need to turn this 2 into a 0. How do you think I'm going to do that? Well, remember how we got those other zeros? We used the 1 to help us get a negative 2 to add to this positive 2. So I'm going to take negative 2 times what's in row 2 and add that to row 3. So that's going to replace what's in row 3 now. Row 3 is going to become negative 2 times row 2 plus the current row 3. So row 1 is not going to change. I'm just going to copy that over. 1, 0, negative 3, negative 2. Row 2 is not going to change. It's still going to be 0, 1, 7, 11. But I'm going to do this to get the new row 3. I'm going to take negative 2 times whatever's in the middle and add it to whatever's on the bottom. So negative 2 times 0 is 0, plus 0 is 0. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times 7 is negative 14, plus 7 is negative 7. Negative 2 times 11 is negative 22, plus 8 is negative 14. Okay, now we have the second column the way we want it to look, and we turn our attention to the third column. So right now the third column has a negative 3 and a 7 and a negative 7. But what I want it to have is a 1 down here on the bottom row, because that's going to be the leading one of row 3. And I want it to have zeros everywhere else in rows 1 and 2. So first I focus on getting the 1 in place. Right now there's a negative 7 down here. To turn a negative 7 into a 1, I'm going to take advantage of that second row operation, the one that says that you're allowed to multiply or divide everything in a row by any particular non-zero constant. So what I'm going to do here is I'm going to take this bottom row and divide it by negative 7. Or if you'd rather, you could think of it as multiplying through by negative 1/7. So row 3 is going to be divided by negative 7, or multiplied by 1/7. So let's go ahead and take care of that. Right now at this step, we're not doing anything to row 1. It's still going to be 1, 0, negative 3, negative 2. And we're not doing anything to row 2. It's still going to be 0, 1, 7, 11. But we're taking everything in row 3 and dividing by negative 7. So 0 divided by negative 7 is still 0. And the other 0 divided by negative 7 is still 0. And the negative 7 divided by negative 7 is 1, just like we planned. And then the negative 14 divided by negative 7 would be positive 2. Okay, so that takes care of that. So now we have the 1 in place. And the next thing to do is, with the help of that 1, we want to get zeros here and here, everywhere else in that column. So this -3 up here has to turn into a 0. What can we add to a -3 to turn it into a 0? I believe that would be a +3. Where are we going to get a +3 from? Well, we can take 3 times what's in row 3 and then add that to row 1. So that's what we're doing to row 1. We're taking what's there now and replacing it with 3 times row 3 plus row 1. So we're adding 3 times row 3 to row 1. Let's go ahead and see what that gives us. The bottom row is not changing. It's still going to be 0, 0, 1, 2. But on top, we're taking 3 times whatever's on the bottom and adding it to what's on the top. So 3 times 0 is 0 plus 1 is 1. 3 times 0 is 0 plus 0 is 0. 3 times 1 is 3 plus -3 is 0. And 3 times 2 is 6 plus -2 is 4. Okay, what about this middle row? There's a 7 that we want to turn into a 0. How do we kill a 7? With a -7. Where are we going to get a -7 from? Take -7 times this 1 and then add it to this +7. So that's what's happening to row 2. We're taking -7 times row 3 and adding that to row 2. -7 times whatever's on the bottom is getting added to what's in the middle. So as we go across, we take -7 times 0 is 0 plus 0 is 0. -7 times this 0 would be 0 plus this 1 would be 1. -7 times 1 is -7 plus 7 is 0. And -7 times 2 is -14 plus 11 is -3. Notice that we did not mess up anything in these first two columns. We didn't undo any of the work we'd already done by what we were doing here. And at this point, what we have is in reduced row echelon form. It fits all the conditions of being in reduced row echelon form. Each row has a leading 1. The leading ones go further down as we go along from left to right. They have zeros above and below them. Now notice what this is telling us. The first row of the matrix says that 1 times x plus 0 times y plus 0 times z equals 4. So that just means that x is 4. The second row is telling us that 0 times x plus 1 times y plus 0 times z is equal to -3. And the third row of the matrix is telling us that 0 times x plus 0y plus 1z equals 2. So we have our solution. X, y, and z have to be 4, -3, and 2 in that order. So if you want to write that as an ordered triple, it would just be 4, -3, 2. So if you go back to the equations that we started with and plug in 4 for x and -3 for y and 2 for z, you should find that all 3 equations are true. That is the solution to the system. That's what x and y and z have to be for all the equations to be true at the same time. So I already went over how you would do that on the graphing calculator. There are also apps that you can get for your phone or tablet that will do this Gauss-Jordan elimination for you. I found one that's called MatCalc that seems to work pretty well, but there are others out there. There are also online matrix calculators, web-based, and I put links to several of those on Canvas. You can try them out and find the one you like best. And it says here you can use these on homework but not on a test, but actually, since we're in this unusual circumstance, I would allow you to use something like that on a test. Okay, I'm going to come back in another video and work through some more examples.